Yes. Hello everyone. So now we are discussing today a question based on 1D motion and based on relative velocity. Okay. So previous questions were two-dimensional motions, the dog chasing the cat and the KLM and moving towards each other, right? That was all 2D motion. This is a one-dimensional motion. So let us see the question first. Please look at the board. You have the question as an open lift is moving upwards with a velocity of 10 meter per second. It has an upward acceleration of 2 meter per second square. A ball is projected upwards with a velocity of 20 meter per second relative to the ground. Find the time when the ball again meets the lift. That means the ball is projected from the lift upwards with a speed of 20 meter per second. Now what all things you need to find out? Time when the ball meets the lift again, okay, and displacement of the lift and the ball at that instant, distance traveled by the ball up to that instant. They're asking us to take g as 10 meter per second square. Okay, so what are the data given in the question? So question says that you are having a lift. Okay, so let us say this is our lift. This is moving upwards with a velocity. It's moving upwards with a velocity of 10 meter per second, and it's moving up with an acceleration of, I think, 2 meter per second square, right? That's what they're given in the question. Yes, 2 meter per second square. Okay, and I'm going to throw a projectile, a ball or something I'm throwing from here, and I have a speed of 20 meter per second. This is the speed given to that ball. Now here, because it's a relative velocity concepts, we have to be clear with respect to what all the data are given. They didn't say anything about the lift, but generally if nothing is given in the question, we would assume that velocity of the lift that they are giving is with respect to ground, that is given as 10 meter per second, and acceleration also given for the lift, that also with respect to ground, that is 2 meter per second square. Okay, now I have this ball's velocity. Now in the question they have specifically said that the ball is projected upwards with a velocity of 20 meter per second relative to the ground. That's what they're saying. So relative to the ground. So this is velocity of the ball with respect to ground as 20 meter per second. Okay, and acceleration due to gravity is anywhere there. So what is the acceleration experienced by the ball, if you ask me? Because right now at this moment of projection, the ball is in contact with the lift, but the next moment the ball will leave the contact, and when the ball leaves the contact with the lift, it is actually in air, right? It is just in air with no contact. So the only acceleration that it experiences is what? Gravity. So I can say acceleration of the ball with respect to ground, what it experiences is nothing but the g, which is 10 meter per second square. This is the acceleration it experiences. Okay, now I can solve this question in two ways. Okay, so the first method is I can assume that my observer is on the ground somewhere and he is looking at the ball as well as the lift, and what the observer will see, he'll say that okay, the ball is going up and the lift is also going up. The ball is obviously faster than the lift initially, so that's why the ball would overtake the lift, and at one point both of them would meet again. Okay, so there we'll have to write two equations, one equation for the ball, another equation for the lift, and we can say that because they are meeting, the final displacement of the ball and the lift should be same. Because I hope you understand, right? Somewhere here, let us say they are meeting, so that means the lift has also covered that much displacement in that time, and the ball has also covered that much displacement in that time. So I can write two equations like S is equal to ut plus half at square, two equations. Time would remain same, S would remain same, U will be different, A would be different. I can solve that two equation and I can get the time. That is one way. But I would try to follow here relative velocity, okay, relative motion concept. I will keep my observer not on the ground but on the lift. Let's think in this way. If the observer of mine is in the lift, then what would the observer say? All the things I have to find now, all velocity, displacement, everything I'll have to find now with respect to the lift. That's the whole point, right? So I can say now, with respect to this observer, the velocity of the ball with respect to lift, we'll say, right? With respect to observer, now with respect to lift. So velocity of the ball with respect to lift is nothing but velocity of ball minus velocity of lift. This is the standard formula of relative velocity, right? These are all with respect to ground. Okay, they are vectors, so I have to write accordingly. Velocity of ball with respect to lift, I don't know, but these two I know. So I can substitute that. Velocity of ball with respect to ground is 20 upwards. So I'm considering positive, minus velocity of lift with respect to ground is also upwards 10. So I'm considering positive. This comes out to be 10 meter per second. Now this is the velocity of the ball that the observer in the lift would see. Okay. Now similarly, acceleration, it's an accelerated motion. So with respect to the observer, what's the acceleration? That also I need to know. So I can say acceleration of the ball with respect to lift is nothing but acceleration of the ball minus acceleration of the lift. This is also a vector. Okay, so this is also with respect to ground. This is also with respect to ground. So ball with respect to ground. What is acceleration of ball with respect to ground? 10 g, right? 10 meter per second square. Forget about meter per second square. Unit we'll write later. Okay. Okay. So, but there is one problem. The acceleration that is happening on the ball g, that is downward. So I should consider downward as negative. That's my everything upward I'm considering positive. So downward should be automatically negative. Minus acceleration happening to the lift. It's accelerating upwards. So this would be positive of 2. So this will finally become minus of 12 meter per second square. So now I have velocity of the ball with respect to the man. Okay, man is in the lift, so with respect to lift I have that, and I also have acceleration that is experienced by the ball with respect to lift. Now finally they said right now the ball is projected, finally the ball will meet with that lift again. So what is the displacement of the ball with respect to the lift finally? It's 0, right? Because according to this man, initially the ball was on the lift, and finally when the lift reaches here, again the ball is going to touch the lift. So with respect to the man, initially the ball was on the lift, it goes up, and then finally again it is on the lift. So final displacement should be 0. So displacement of the ball with respect to lift comes out to be 0. So now I can use the formula S is equals to ut plus half at square. S is equal to 0. U value that I am having is basically 10 into t, no idea. And this acceleration is downward. So accordingly I will put negative sign, minus of half into 12 into t square. This is what I'm getting. Okay. And now just solve this. So you can take this becomes 6. You can take 2 out common. So you'll be getting 2 times 5t minus 3t square equal to 0. This is the equation. So from here I can get 2 values. One is t equal to 0. This is one solution. Or t is equals to, I'll be getting 5 by 3 seconds. Okay, t equal to 0, that's the initial case. So that I already know that initially the ball was in contact with the lift. So that is an irrelevant answer. I don't need that. This is the relevant one. So the ball will again touch the lift in 5 by 3 seconds. Clear? Alright, so that was the first part. What about the second part? What they're asking in the second part of question? They're asking us to find out displacement of the lift and the ball at this instant. Now the moment you have the time, now what can stop you from finding the displacement, right? So if you are interested in finding displacement, please use the formula again. S is equals to ut plus half at square. This time you are having the time. Use this formula separately for both of them because they are asking displacement of the lift and the ball. So obviously if nothing is mentioned, this is displacement with respect to the ground they're asking. So I will have to use, first of all, for the lift I can say displacement of the lift is nothing but what is initial velocity of the lift? 10 upon 10 into 5 by 3 and plus lift is accelerating upward, so positive, right? So I can write half into 2 into 5 by 3 square. Okay, so this would give me how much? So this will become 50 by 3 plus 25 by 9. Okay, so this would be 150 plus 25 by 9. I am getting the answer as 175 by 9 in meters. So this is the displacement of the lift in that same time. What about displacement of the, let's say, ball? Okay, so displacement of the ball comes out to be, again you have to use the same formula. You can say displacement of ball is equals to, we can write what is that? Displacement velocity of the ball is actually 20, okay, into 5 by 3 minus half into, minus because it's acted by g, that's why, minus half into 10 into the time is will be again 5 by 3 square. But if you are thinking, if you are using your brain right now, you would tell me that, sir, why are you calculating that thing again? Shouldn't the answer come out to be same? That's correct. The answer will come out to be same. The displacement that the lift has done and finally the displacement that the ball has also done should both be actually equal. So you don't need to calculate again the displacement of the ball. If you want to, you can use that substitution, calculate it, you should get the same answer. So it doesn't matter, we don't need to calculate. Let us go to the third part of the question. The third part of the question says, find the distance traveled by the ball up to that instant. Okay. Now distance traveled by the ball. Distance is always tricky. Why tricky means? Displacement, for displacement I am directly having the formula, but when it comes to distance, formula doesn't work. You have to be careful in the sense, is the body only moving in forward direction, or during that journey of 5/3 seconds somewhere is my body reversing? That's also important, because if my body is reversing, displacement will not count for that extra distance. Displacement will be only counting the initial and final position. So when we want distance, we have to be careful about that. So first thing that we have to check is, during the motion of the ball, when is it stopping? Okay, in how much time will my ball stop? So let us check that. So if I want to find out when the ball stops, I can use the formula v is equals to u plus at. This is the easiest one. Final velocity of the ball when it becomes 0, and the u value, how much is the u value initially? They have given 20 meter per second upwards, minus g value is minus, that's right, minus 10 into t. So I'm getting t is equals to 2 seconds. So that means my ball would be reversing its journey only after 2 seconds. Until then the body is going, my ball is going in a straight line in one direction. And in how much time the lift and the ball is meeting? That is meeting in 5/3 seconds. So can I say that 5/3 is lesser than my 2 seconds? Right? But that means the lift and the ball would be meeting before the ball could stop. So that means during this moment, during this time of 5/3, isn't my ball always moving in one direction upwards? If that is the case, I don't need to calculate displacement and distance separately. I can just say distance will be equal to displacement, because the body is moving in one direction only, and my answer would become 175 by 9 meters. Same answer. Okay, I hope you are clear with this. The concept was actually easy only, but we can categorize this question into also a JEE Advanced, because they can be making you confused. Okay, they can make you confused actually in this topic of displacement and distance. Many times I have seen that in this silly concept, actually students are making mistake. So make sure to solve questions based on this, where they are giving you some equation and they're asking you to find out distance and displacement separately. Okay, I will also try to take one more question on the same topic. I hope you have understood. Again, if you have understood, please like the video and make sure you comment, and please share it with your friends and all who wants to understand. Okay, thank you.